Okay, so partial fractions. So we're going to start off with this, and then I'm going to write that factor just to save myself a little bit of space here. So multiplies to 3, adds to be negative 4, sounds like x minus 1 and x minus 3. And then from here, what we're trying to do is write it in the form where it's two separate fractions. And the reason is in Calc 2, this is really hard to integrate, and when you can write it in this form, it's much easier to integrate. So being able to change forms has an advantage in a later course. And the deal is, if I have something that has this denominator, it must have come from things that had those same denominators in terms of the partial fractions. So the same way that if I have 5/6 1/2 plus 1/3, 6 is 2 times 3. So if something's going to come out to 6's, it had to originate from 2's and 3's, or possibly 1's and 6's. So that is what we're doing there. So just undo that. And so we're going to allow these numerators to just be variables and figure out what, if I put them up here, would make it come out to when I added these, we'd get back there. When we get to the end of the problem and I have those numbers, unless they're super terrible. Let me see how terrible the answer is on this. Oh no, they're going to be fine. I'll show you. Actually, let me just show you right now. 3x minus 1 plus 3x minus 3. So if we remember back in chapter 8, to add these, we would do an x minus 1 right there. And then this side would need an x minus 3, x minus 3. This would be 3 times this stuff, so 3 times x would give me a 3x. 3 times 3 gives me a negative 9. Here, 3 times x would be a 3x. 3 times negative 1 would give me a negative 3. All over that LCD. Collecting terms, 3x plus 3x is 6x, and then negative 9 minus 3 is negative 12, and that's over x minus 1 and x minus 3. And so if you look, I'm right back at what it gave us. So what we're trying to do is, what would I break this apart to as two fractions that when I add it gets me back to here. And so we're just setting this up with the a and the b to allow for these numerators that I don't know. I know the denominators because they're right here. But I'm trying to figure out what is going to make that come out true to this. So that is the goal of this, is to get to this form, which is another form of that fraction. So in terms of the nuts and bolts of doing that, there's two methods, and it depends on how many zeros you have. In this case, I have two variables I need to find, and I have two zeros. So what I described in the video as method 1 is definitely the easiest way to do this one. Our first step, no matter what, is to multiply both sides by the LCD and clear the fraction. So this right here is my LCD, so I'm just going to write LCD right there. And I'll write it out on this side. So that cancels, and I would have 6x minus 12 equals, and then the a minus 1s would cancel. If you kind of picture that, here I could just write it there. X minus 1, x minus 3. Then those minus 1s cancel, and I'm left with a times x minus 3 plus b. There, the x minus 3s would cancel, so b times x minus 1. So no matter how we're going to solve it, that much is the same. And then from here, I can either start distributing stuff out and trying to get two systems of equations, or a system of two equations out of it, and then I can solve that. Or if I have zeros, I can plug those in. And in this case, I have two zeros from the denominator. I have x equals 1 and x equals 3. The reason those are good is that, let me throw in the x equals 1 right here. If I do that, I get 6 times 1 minus 12, and then equals a, 1 minus 3 plus b. And right there is why we like the zeros, is because then I get a 1 minus 1, and that whole thing just drops out. And then I can just solve for this last little piece here. So 6 minus 12 would make negative 6 equals 1 minus 2 being negative 2a, and then dividing that negative 2 over, there's our a equals 3, like we saw when we did the answer. And then do the same thing with the other 0, x equals 3. And we'll plug it right back in here. 6 times 3 minus 12 equals, this piece I don't even have to write because it's just going to go 3 minus 3 is 0 times a, and that dropped out. So it will equal b, and then 3 minus 1. So 18 minus 12 is 6, and that equals 3 minus 1 would be 2b. Then dividing the 2 on both sides, there's our b equals 3. And then that's how we get that final answer. A is 3, so 3 over x minus 1. And then b is 3 again, so x minus 3. So again, when we add these together, like we did in chapter 8, we get back to this. So it's kind of the same thing as we did in chapter 8, but unfortunately in reverse, which is definitely significantly harder. But anytime you have the zeros, like in this one, definitely use the zeros. And then in the long video, I talk a bunch more about the 2 different methods, but this one is definitely method 1, and that's about what there is to it.